Hello everyone, I am Anushriyar, Assistant Professor, Department of ECE. Today we are going to study some of the concepts on GSM channel concept, which is taken from the GSM and TDMA technology, which is a topic in wireless and cellular communication, 18 EC 81 subject in 8th semester. The previous videos we have already seen how the network interface has been divided in GSM network, the how the frequency carriers, channel concepts, everything has been discussed in the previous videos. Now moving on forward, let us have a look at the channel concept. Before going into channel concept, let us have a look at the GSM-TDMA frame. Cellular telephone networks use various control and traffic channels to carry out the operations that is necessary to allow for the setup of a subscriber radio link for the transmission of either a voice conversation or data and the subsequent system support for the subscriber's mobility. The GSM cellular system is based on the use of TDMA, that is time division multiple access, to provide additional user capacity over a limited amount of radio frequency spectrum. As we can see here, the TDMA structure which is shown here, the GSM system divides the radio link connection time into 8 equal parts. That is, if we can observe from TS0 to TS7, that is time slot 0 to time slot 7, 8 equal and repeating time slots. We can see it is repeating either on left, both on right and left sides. These repeating time slots are called as frames. This would be for both uplink and downlink transmissions. The time slots can be considered logical channels. That is, from a system point of view, each time slot may carry either subscriber traffic or it can also carry a signaling and control information which is required for the management of radio link and other system resources. The system can use several different types of repeating frame structures, which is known as multi-frame, depending upon the type of information being transmitted. Now, after knowing this, let us focus on the channel, that is logical channel. The logical channels are the one which carry either subscriber traffic or the signaling and control information to facilitate subscriber mobility. There are three types of traffic channels, that is traffic channels which is shortly called as TCH, three types. The full rate traffic channel, that is TCHF, carries one conversation by using one time slot. The half rate traffic channel carries voice encode, that is only one, and the enhanced full rate, that is EFR, transmission codes in traffic encodes a voice as well as at a rate of 12.2 kilobits per second rate, and like TCH bar F adds overhead bits to yield 22.8 kilobits per second channel rate. Now moving on further, the broadcast channels are of three types. That is, the signaling and control channel consist of three channel subcategories. The three categories are broadcast control channel, frequency control channel, and the synchronization channel. Now, the broadcast control channel. With the broadcast control channel, the GSM cellular system uses BCH, that is broadcast channel, to provide information to the mobile station about various system parameters and also information about the location area identity. The three types of BCH are broadcast control channel, frequency control channel, and the synchronization channel. Using the information transmitted over these three BCH, the mobile station can tune to a particular base transceiver system and synchronize its timing with the frame structure and timing in that cell. Each time the mobile station attaches to a new BTS, it must listen to these 3 BCHs. At present, the timing of different GSM cells is not synchronized. However, there are several emerging technologies which can adopt in the near future. The use of the single antenna interference cancellation algorithms to increase the GSM system capacity is also being used to overcome this. The next one is the broadcast control channel. The broadcast control channel contains information that is needed by the mobile station concerning the cell that is attached to it in order for the mobile station to be able to start making or receiving calls or to start roaming. The type of information broadcast on the BCCH includes the LAI, the maximum output power allowed in the cell, and the BCCH carrier frequencies for the neighboring cells. Next comes the frequency control channel. The frequency control channel FCCH transmits the burst of zeros and to the mobile station. This signaling is done for two reasons. The first one is the mobile station can use this signal to synchronize itself to the correct frequency, and the next reason is the mobile station can verify that this is the BCCH. Next comes the synchronization channel. The synchronization channel is used to transmit the required information for the mobile station to synchronize itself with the timing within a particular cell. The next channel that we are going to study is common control channels, that is CCCH. Here, the common control channel is going to provide paging messages to the mobile station and a means by which the mobile can request a signaling channel that it can use to contact the network. The three CCHs are paging control channel PCH, random access channel, that is RACH. Next one is the access grant channel. The paging channel is used by the system to send paging messages to the mobiles attached to the cell. The mobile station listens to the PCH at certain time intervals to learn if the network wants to make contact with it. Next comes the random access channel. The random access channel is used by the mobile to respond to a paging message. If the mobile receives a page of the PCH, it will rely on the RACH with a request for a signaling channel. The next comes the access grant channel. This is used by the network to assign a signaling channel to the mobile station. Next one is the dedicated control channel. These dedicated control channels are used for specific call setup, handovers, measurement, and short message delivery functions. This is shortly called as DCCH. Out of this DCH has 4 DCH channels. One is the standalone dedicated control channel SDCCH, the slow associated control channel SACCH, fast associated control channel FACCH, and the cell broadcast channel, that is CBCH. Standalone control channel, both the mobile station and the BCS switch over the network assigned standalone dedicated control channel, and this that is assigned over the access grant control channel in response to the mobile's request that has been transmitted over the random access channel. The call setup procedure is performed on the SDCCH. Slow associated control channel. The slow associated control channel is used to transmit information about measurements made by the mobile station or instructions from the BTS about the mobile's parameters of operation. Fast associated control channel is used to facilitate the handover operation in a GSM system. If handover is required, the necessary handover signaling information is transmitted and with a 20 millisecond segment of speech over the TCH. Next comes the cell broadcast channel. The cell broadcast channel is used to deliver short message service to the downlink direction. Now moving on further, we are going to study about the speech processing, how the speech processing is going to happen. The block diagram shown here is going to depict the process that is going to happen in the speech processing. With this, we are going to study, with this block diagram, we are going to study the speech processing system. That is, in the mobile, speech is digitized and broken up into 20 milliseconds, which is shown here. 20, shown here. That is 20 milliseconds, broken up into 20 millisecond segments. It is then coded to reduce the bit rate and to control the errors. This process is going to produce an 8,000 samples of 13 bits per second. So you can see here 13 bits per sample per second, or even it is 160 samples of 13 bits. The speech coder yields 260 bits per 20 millisecond or 13 kbps, whereas channel coding yields 456 bits per 20 milliseconds or 22.8 kilobits per second data rate. Interleaving, ciphering and burst formatting yields 156.25 bits per time slot. This yields an overall data transfer rate of about 270.8 kbps over a GSM channel. The channel model is created in the equalizer, where an estimated bit sequence is calculated for a received signal. After all the burst containing information about a 20 millisecond bit sequence estimated is calculated for a received signal. After studying this, let us move on for the TDMA hyperframe structures. Okay. In a GSM system, both traffic and signaling and control information are transmitted. The TDMA frame, in the TDMA frame in which we are seeing, this is what TDMA frames. In the GSM system, 8 time slots constitute a TDMA frame. That is what, from 0 to 7 constitute frame. The system assigns numbers to the frames sequentially from 0 up to 2,715,648, and the process repeats itself. Right? Now, this grouping of successive TDMA frame is known as hyperframe. We call it as hyperframe. The grouping of successive. Now, the hyperframe consists of 2048 superframes. We can observe here 2048 superframes, and takes 3 hours 28 minutes 53 seconds, that is 760 milliseconds to complete that. Each superframe consists of 1326 TDMA frames that take approximately 6.12 seconds to complete. These superframes may take on one of two possible formats. Now, after knowing this, let us move on to the time slots. The organization of the transmitted digital bits within the air time slot itself can take on several different formats depending upon the type of information. Now, moving on to the air interface that we are going to study in the next slide. So, the air interface that we are going to have here is, time slots has a duration of 3 by 5200 seconds, or approximately 577 microseconds, whereas the typical transmitted burst is approximately 546 microsecond. Phase, a bit frame is 48 by 13 microsecond, or approximately we can say it is 3.69 microsecond. The start of TDMA frame on the uplink is delayed by 3 time slots. If we have a look, if we have a detailed look of this, we can see here there is a delay version of 3 time slots, right? So, delayed by 3 time slot periods from the downlink frame. The purpose of this delay is so that the same time slot may be used on both the downlink and the uplink radio paths without the need for the mobile station to receive and transmit at the same time. This extends mobile battery life, and it also makes easier for the mobile's hardware to implement the radio frequency operations needed for proper system functioning. Next comes the time slot burst. Now what is this time slot burst? We can have a look here. So the time slot burst So this is a time slot burst. The transmission of a normal burst and the other types of burst signals, which we can see here, right? So these are the burst access burst, frequency correction burst. Okay. So in case of a normal burst, two groups of 57 encrypted bits are transmitted on either side of a training sequence of bits. This training sequence consists of alternating zeros and ones and is used to train the adaptive equalizer incorporated into the GSM mobile receiver. Three tail bits precede first group. So this is the three tail bits precede the first group of traffic bits and three tail bits at the last group of traffic bits. These tail bits consist of three zeros that provide time for the digital radio circuitry to initialize itself. The flag bits are used to indicate, that is, these are the flag bits which are used to indicate whether the encrypted bit contain traffic or control information. The frequency correction is used by the mobile to obtain frequency synchronization. It consists of 142 fixed bits preceded by 3 tail bits and followed by 3 tail bits. It also has the same 8.25 long guard bit. So this is what GP guard bit, guard period after it. The repetition of the frequency correction burst by the BTS within the GSM frame structure becomes the frequency correction channel. The synchronization burst. Synchronization burst is used by the mobile to obtain timing synchronization. Again, this also consists three tail bits at the beginning and three tail bits at the end with the guard bit, with the guard period bits, where it is followed by 39 encrypted bits, 64 bit synchronization sequence and 39 more encrypted bits and 3 tail bits. Now moving on, we have something called as access burst. Is used by the mobile to facilitate random access request by the mobile and handover operations. If we observe, we have 8 tail bits here with a 41 bit synchronization sequence and then 36 encrypted bits for the encrypted bits. Next is the dummy burst. We have dummy burst is transmitted on the radio frequency designated as C0 when no other type of burst signal is being transmitted. This affords the mobile with ability to make power measurements on the strongest BTS in its location and thus determine which BTS to attach to when first turned on. So this is about the GSM traffic and control burst, signal burst. Thank you for watching.